Hello students, today's agenda is to check your homework. We're going to go over the quadratic equation, and the assignment for today is 10.13. Today students will be able to solve quadratic equations by using the quadratic formula. And so I'm going to go directly into that. Let's see. So the quadratic equation, I already showed you a song. Let me see if you can see it. It's x is equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so this is how you write it down. So x is equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I would like for you to write down the song, to write down the formula, remember it, and we're going to be doing some examples right now of how to apply it. So maybe pause it and take note of that. In general, we will need our quadratic equations to be in this form. Ax squared plus bx plus c is equals to 0, where a, b, and c are numbers or integers, okay? And once you see specific examples, I think you're going to be more familiar with or understand what we're talking about, okay? Okay, so let's start with the first example. And so we have x squared plus 7x plus 12 is equals to 0. We're going to write our a, b, and c in here. And so if we look back at the general equation, a is always with x squared, b is always with x, and c has no variable. Okay, and it's always equals to 0, always equals to 0. Okay, so a is always with x squared, so since we don't have a coefficient in here, that means that a is going to be 1. B is always next to x, so that will be positive 7. And c is going to be positive 12. So the quadratic equation is x equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. In here, in the quadratic equation, we're going to be replacing the values of a, b, and c, but then there are also some values that are always going to be there, like the negative 4, it's always going to be part of the equation, and 2 is always going to be part of the equation as well. So if we have x is equals to negative b. Negative b means negative from the equation, and b is 7, so it becomes negative 7 instead of this positive 7 in here. Plus or minus the square root of b squared, so again we get the value of b, which is 7, and square that, minus 4, which is always part of the formula, times a, which is 1, times c, which is 12. All over 2a, meaning 2 multiplied by a, which is 1. So x is equals to, we're going to start simplifying whatever parts we are able to simplify. For example, this part right here and this part right here. Oh, and even this part right here. So we bring down the negative 7 plus minus the square root of 7 squared would be 49, and then negative 4 times 1 is negative 4, and negative 4 times 12 is negative 48, and 2 times 1 is 2. So you can see that we're simplifying each time more and more. The next part that we can simplify is this part inside of the square root. So we bring down the negative 7 plus minus the square root of 49 minus 48 is 1, and nothing else. I shouldn't have done it so big. All over 2. And so in here, we have negative 7 plus minus, what is the square root of 1? It's 1 divided by 2. And so in here, we're going to take two paths. Remember that we're adding the 1 from the, to the negative 7, and we're subtracting 1 from the negative 7. So it's two different paths. So you're going to get x is equals to negative 7 plus 1, negative 6. And you just bring down the 2. Now with the other side, with the minus 1, negative 7 minus 1, that's negative 8 divided by 2. And so we can simplify that to be negative 6 divided by 2 is negative 3, or negative 8 divided by 2 is negative 4. So those are going to be my two different answers. Again, remember that this relates to, oh, my parabola is going to be intersecting at negative 3 and at negative 4. So my parabola might be something like that, okay? Again, we'll see more about the graphs later on. Okay, so the question is, when would I use this, and when would I use completing the square? When would I use the diamond? When would I use the greatest common factor or the perfect squares? Well, let me tell you that the quadratic equation can be used with any of the ones that we have seen prior to the quadratic equation. It's just a matter that sometimes it would be easier. So let me go back to this one to show you that sometimes it's easier to use the other method, but when it comes to other complex ones, it's better to use this method. So we notice that this is a number multiplied that makes 12, but added makes 7. Well, it's 3 times 4. We open our parentheses, and instead of doing the quadratic equation, we do factoring. So x plus 3, x plus 4. And to solve, remember that we equaled each of the factors to 0. And we started solving. So we would subtract 3 from both sides. And so x equals negative 3. In here the same. And so x equals negative 4. If you notice, we get the same answers, right? We have negative 3 and negative 4, just like we did in here, using something that we knew before, which is factoring. Again, you can use either one, that's fine. But for today's assignment, I want you to use the quadratic equation. Okay, so for this next example, our A is the coefficient of x squared, which is 1. B doesn't have a coefficient, it's also 1. And C does, we have the 1 in here, so for all of them, we're going to have 1. So x is equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we start negative from the formula. B is 1 plus minus the square root of b squared, which is 1 squared, minus 4 times a, which is 1, times c, which is 1, all over 2 times a, which is 1. Lots of 1s right now. And so we bring down negative 1 plus minus the square root of 1 to the second power is 1, minus 4 times 1 times 1, that will be minus 4, all over 2 times 1 is 2. And so we are going to have negative 1 plus minus the square root of 1 minus 4 is negative 3 all over 2. And so we have negative 1 plus minus. We cannot simplify the 3, but we can simplify this negative by putting it as an imaginary number. And remember that the radical comes after the imaginary number. And it's all over 2. Since we can't simplify anymore, that's going to be my answers. This is going to be it. Okay, another example. Now in here, there's something different. If you recall, we need to have everything equals to 0. So what are we going to do? We need to cancel these 5. And so we're going to subtract 5 from both sides so that this can be on the other side of the equation. And so now we have x squared plus 4x minus 5 is equals to 0. Now we have it in the form that we need to have it. And so a equals 1, b equals 4, and c equals negative 5. Okay, so we start with the equation x is equals to negative b, which is 4. I recommend that you write the equation, but just so that this video is not that long, I'm going to skip that part. So negative b plus minus the square root of b squared minus 4, that's part of the equation, minus 4a c, including the sign, all over 2a, which is 1. And so this is equals to negative 4 plus minus the square root of 4 squared is 16. Negative 4 times 1 is negative 4. Times negative 5 is positive 20. All over 2 times 1 is 2. And so we have negative 4 plus minus the square root of 16 plus 20, 36, divided by 2. And so we bring down the negative 4 plus minus. The square root of 36 is 6 over 2. And so both paths, adding the 6 and then subtracting the 6 from negative 4. So when we add 6 to the negative 4 is positive 2 divided by 2. Or when we subtract negative 4 minus 6 is negative 10 over 2. And so my answers will be 2 divided by 2 is 1, or negative 10 divided by 2 is negative 5. Okay, so those will be the values of x. Okay, what about when we have a coefficient? Same thing, all we're doing is just replacing instead of 1, a 2 in the a. So my a is the coefficient of x squared, so it's 2. B is the coefficient of x, so it's 7. And c is the constant number, so it's 3. Again, x is equals to negative b, negative 7. Plus minus the square root of b squared, so 7 squared. Minus 4ac, minus 4a, which is a 2, c, which is a 3, over 2 times a, which is a 2. You might want to have the quadratic equation in front of you as well and write it again and again, okay? So negative 7 plus minus the square root of 49 minus 4 times 2 is 8. 8 times 3 is 24, all over 4, because we multiply this. And so that's equals to negative 7 plus minus the square root of 49 minus 24 is 25, all over 4. This is negative 7 plus minus the square root of, the square root of 25 is 5, so I don't need the square root anymore. Okay, can't find the white out. It's okay. So this is a 5. The square root of 25 is 5, all over 4. And so negative 7 plus 5, it's negative 2 over 4. Or negative 7 minus 5 is negative 12 over 4. And this simplifies, this can only be reduced. So it's going to be negative 1/2, because both are divisible by 2 by 2. Or negative 12 divided by 4 is negative 3. So these are going to be my two answers for x. Okay, two more examples. And we have 5x squared plus 5x equals 0. Uh-oh, only two terms. So what is a? A is always with x squared, so that will be 5. B is always with x, so that will be 5. And C, we're not adding a constant, so that will be 0. We need to include that, okay? So x is equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we bring down the negative 5 plus minus the square root of 5 to the second power is 25. And then in here, we're going to be subtracting 4 times 5 is 20. 20 times 0 is 0. Divided by 2 times 5 is 10. And so in here, we bring down the negative 5 plus minus 25 minus 0 is 25. So the square root of 25 over 10. X is equals to negative 5 plus minus the square root of 25 is 5 over 10. And so we do both paths, with the plus, with the minus. So negative 5 plus 5, 0 over 10. Or negative 5 minus 5, that's negative 10 over 10. And so x is equals to, whenever we divide 0 by a number, it's always 0. Or negative 1. Sorry about that again. Okay. So 0 divided by 10 is 0, and negative 10 divided by 10 is negative 1. Okay, you can write in the meantime this example. Okay, sorry about that. So A is going to be 2. B is always with x. And so this is where you want to be careful because we don't have x in here. So that means that my B is 0. Yes. And so my C is going to be 6 because C is always the constant number. So x is equals to negative B, which is negative 0, plus or minus the square root of B squared, again 0 squared, minus 4A C, and all over to A. So it's gonna be, if you think about it, minus 0, it doesn't really matter. So you're just gonna have plus minus the square root of 0 squared is 0. And then negative 4 times 2 is negative 8. Times 6 is negative 48. All over 2 times 2 is 4. And so we're going to have something very interesting in here. We have the 48. The negative automatically becomes the imaginary number. And so we're going to start simplifying. We're going to start simplifying the 48 in here by doing the prime factorization. So 8 times 6, 2 times 4, and 2 times 2. For the 6 is 2 times 3. And so I start making pairs. Remember that we cross one out, and so those 2 times 2 will be the 4 that you're going to put in here. And we have a 3, which is the square root of 3 in front of it, all divided by 4. So you can simplify one more step farther, but I think I'm just going to leave it like that since there has been a lot of interruptions today. So sorry about that.